ma'am.
What okay?
Yeah, this thing is getting cut, ma'am. That's why I can't understand.
I said this mobile is hating me today. That's what it is taking my name. I said.
Hating you. Okay.
Said okay, let them join because no one has joined. You and me only are there.
Yes, ma'am.
Wait.
Wait, ma'am.
Okay, fine.
Ma'am, we'll wait for more 5 minutes and then you start, ma'am.
Hello.
Ma'am,
Hello.
you start at 2:30, ma'am. Don't wait.
Okay. All regular students have come.
No, ma'am.
You just send over one WhatsApp message to them for courtesy.
Okay, ma'am.
Because we will respect them, whether they respect or not doesn't matter. Can you send or shall I send? What will do?
I've already sent, ma'am.
You already sent. Thank you.
No problem, ma'am.
What we have seen in the last class?
Ma'am, rapids and filters.
Okay, in that what we have seen?
It's classic. I actually don't remember where you ended because I did this assignment, no, ma'am.
So that is assignment mistake. Okay, not our mistake.
No, ma'am, you also gave us the homework.
Yes, everyone will join. We'll discuss. Those who have not joined homework, for them less -2 in assignment. Okay.
Okay, ma'am. I don't think so. Everybody remembers the homework.
Then why should I have given that homework? What is the need of it?
Yes,
ma'am.
No,
Oh, my name is not displayed, so people may think that I have not yet started or what?
That's what.
Okay, already madam started on the name of Galaxy M02. Can we send a message?
Can you? No. Once they join, then only they can see, ma'am. Otherwise, they will not know who all are there in the class.
Yes, that is true.
Yeah, once they join, they can hear your voice, then they will all know that you are speaking.
Yes.
But the last classes, ma'am, last 45 minutes went above the head.
About okay, about whose head?
Difficult, ma'am. I read it also, but then it's very difficult to remember everything, ma'am. It's not like other chapters, which are once you read, you
understand. This is because all terms are new terms. Almost 90% all terms are new terms.
Yes,
but 1 or 2 times, if you study well, then you become a master of the subject.
I doubt, ma'am.
The thing is, now you know what is coagulation, what is flagellation, why we have to do filtration, what is sedimentation. That means in filtration means
basic thing, ma'am.
Yeah, that's what for our easy understanding, I will make you small sort of brief. What now you know what is.
Can you give notes on this chapter?
Notes are. You are a school student or what?
No,
when
ma'am.
I'm speaking, you have to take.
That we're taking. I take notes also. But
that's what I told you. Today classes over. Today only you spend half an hour. You will recollect.
I did, ma'am. I'm telling you now. I did the assignment also in this chapter only. That day. But still.
You people, wherever you have struggled, you cannot understand. You ask me. That's what I'll give. What is filter? What the filter means? What? Filter means don't think that whatever the filter you people are using for coffee, tea straining. Okay? Yes, coffee, tea straining and these filters are working with the same principle concept. Everything is same. But here the slow sand filter or rapid sand filter which have separate filter media. Yes. What is that filter media? The filter media is made up of several material which are all coarse in form material. They packed with some of the things. For the packing material has some specific physical chemical characteristics in terms of specific gravity, coefficients of what is that smartness, or we can say equivalence ratio. Many things are there that I will see. 4 or 5 size of the particle, diameter of the particle, volume, and 4-5 parameter for their each. Then they are combined each other and make it as a bed inside some sort of cylindrical column. How is your coffee filter is looking? One filter is there in the middle. You are pouring some dirty material. The filter is filtered that dirty material and the pure liquid is going up. In a rapid sun filter, that filter media is fixed. If you want, you can take it out, but it is not movable. Yes. So through that water, whenever the turbid water it is going on, the turbid particles will be blocked or attached with this filter media. The filtrate, like clear water going down. Based on the movement of this water on the bed, many type of filters we have discussed. Understand? In this concept, wherever the problem will come only in the filter media. When the problem will come, if the filter media will started coming out, that is called pitting. If the pitting is there, then it makes a turbulence flow. Turbulence when it will occur when the fluidization forms. Then these two problems, whenever it forms, the filtration efficiency and quality will go down. This is the problem. Then what we have to do, we wanted to continuously use this filter media means because it is hold the dust particle, turbid particle. There is no way to escape. So if we wanted to take out this means we cannot simply take out from the filter media. We have to give backwash. Means from the backside when you are passing the water with a particular pressure, wherever the turbid particle will go and sit on that coarse material, the porous media of filter media, which will come out. After it comes out, you can take out the filter media, you can grind it, dry it, whatever method you want to do, you make it like a normal material. Then again, you can pack it and use it. So this filter media can be reused. Understood?
Yes, ma'am.
The packing of composition of material, packing of material, they have explained very simply in your book. Actually, if you read some other book, that itself one unit. Okay. Packing material. Okay, this is the one of 4-5 material bituminous, mortars, silica, activated carbon, some kernel seeds, like that only. Yes. Okay. So then based on the flow, there are different types, down flow, by flow, radial flow, decline flow, multi-inlet and outlet flow. And based on the name they have defined. You can go through now constant flow, decline rate. For constant flow means we have to maintain the flow constant at the filter bed, not at any other place. Decline flow means we have to, there's a minimum level we have to maintain below the inlet filter. So this is 2 point is enough for those. Rest of the thing you can, according to the pressure, again it is 2 types, gravity flow and pressure filters. Gravity flow means by natural gravity water flows. Whatever that coffee filter is working, same principle. Pressure filter means there is a point. In a pressure filter, what people are doing, we cannot do in the open column something, we will filter it up. In this particular type, we have to use a separate specific device. In that device only we can pressurize it. Otherwise, normal open system we cannot. Pressurized device, pressurized filter is something different. Where a specialized unit you have to design, there you have to create the pressure for filtration. That is something different. So, for example, instead of pressurized filter, vacuum filter also available. What is meant by vacuum filter? No one in the class
will be there, ma'am.
Huh?
It will be under vacuum. No air will be passed through it, ma'am.
Air will not pass. Air will suck.
Suck. Sorry, suck.
Okay, any one of you has, I think you and me only are talking. No one is there. They have joined and left. Even Dahlia also.
No, they must be there, ma'am.
No, ma'am, I am listening. No, ma'am, I am listening.
Okay, if I mention somebody's name, they are really becoming active. Very good, ma'am. Thank you. Okay. What I want to tell, yeah.
Something. Yes. From understand is due to online class. In offline class, the Scrabble is also look different but difficult. But when you take our class, it comes easy to us.
Madam, I have advised you to talk with the higher authorities. We would like to have only on offline classes. We don't want online class. You go and speak. I told you, na, you people, why you didn't talk? Answer to me. Hello? You went on mute or what? No answer. Yeah, actually, if we will tell also, they will give n number of reason. We are in the modern world. Throughout the international level, people are teaching are doing the course through online only. You people can also do like this. They will say n number of things, but we have to be very strong. Those who are attending the offline classes, they only attend that online class also. So we prefer to have that. We wanted to have that. Please conduct like that. You have to speak. No one is responding. Anything I said wrong?
No, ma'am.
No, ma'am. It's right. But
Ma'am, I don't think so. Anybody more will come. You can start with the class.
Okay, already I started. No, I am explain to you.
Yes, ma'am. Yes, ma'am.
Okay. Now, last time we have stopped at pressure filters only.
Yes, ma'am.
Gravity filters and the pressure filters. Okay.
Yes.
So now we'll talk the type of filters based on the operation. They have classified again 4 types of filters. That is direct filters, diatomious filters, valveless self-washing filters with automatic siphon, and fourth one is the roughing filter. Now I wanted to ask you people really heard my class about the water treatment stages means. Now you answer to me what is meant by roughing filters. You think and answer to me.
Roughing filters, ma'am.
Yes, yes. You can compare with your normal filter also. Then you can get some idea. What happened? Everybody went on mute or what?
Thank you, ma'am.
Roughing filter, that means roughing in the sense.
Rough, suspended particles it moves. Or what?
When the suspended particles are more or if turbidity is more, you people have to remove that. For example, what I have told about the pre-chlorination. Why do you want to do pre-chlorination? There are 2 types of pre-chlorination. One is pre and post.
Yes,
You
ma'am.
know what is meant by pre-chlorination and post-chlorination. Why
Yes.
do we want to do pre-chlorination?
To remove excess of this thing, ma'am. Infection. Yeah. Disinfection process will be there in it, ma'am.
So whenever we can say
Yeah.
contaminant are more, okay,
Yes, ma'am.
if more contaminant are there, before starting up all the conventional process, we have to reduce that contaminant before entering into the other stage of treatment. Otherwise, other stage of treatment efficiency will go down or interfere with that contaminant.
Yes.
To reduce it only, we are doing this pre-chlorination. This rough filtration, which is nothing but a pre-filtration. So what could be the reason? How it could be performed?
To remove extra suspended particles if it's very turbid, the water.
That is the point. Yes.
So we have to remove it.
Okay. Any other answer? Hey, people, everyone should think, na? Okay. Actually, pre-filtration, I will tell you about the rough filtration later. Shall we start from the direct filters?
Yes, ma'am.
Okay. Actually, there are four types of filters I said. First one is direct filter. Direct filter means which is very common. The principle associated with the direct filtration is direct filter is direct filtration. Direct filtration means what? Just we are passing the water through the or turbid liquid passes through any filter media. According to the natural gravity, the water will be flowing down. The turbidity or turbid particles or suspended particles will be laid down at the top or in the course of media. That is direct filters. But the thing is, which involves the unit process, which incorporate with the coagulation, flagellation, and the filtration without the use of sedimentation. Same, all the three processes can be incorporated with a single unit when we are using the direct filtration, because here the flow direction will not change according to the flow of direction. We have seen many filters.
Ma'am,
Upflow, downflow, byflow.
go little slow now, ma'am. Please.
Okay, well, okay. This is involvement.
You're going very fast, ma'am.
That's why this is when I'm involved with the subject more, that automatically will come. I myself don't know that.
Yes,
Okay,
ma'am.
I'll go very slow. Okay, no problem.
Yes, ma'am. Because it's
Okay.
taking us a little time to grasp things. It's new
Yeah.
knowledge.
Yes. Direct filters means what? Which is working on the simple concept of normal filtration process. Actually, which involves a series of process operation that whatever the different stage of water treatment we have seen coagulation, flagellation, and filtration, without the use of any sedimentation technique, we can use this concept. Actually, this direct filtration can reduce that coagulant dosage. Either it is alum or ferrous sulfate. The concentration or the quantity of adding of coagulant into the water dose level will be reduced when we are using this direct types of filters. Okay, in a direct filtration, mostly the rate of filtration is obtained at 4 millimeter per second on a reverse grade. Reverse graded means what? How the how the filter media will be made up? Hello?
Yes, ma'am.
Somebody has asked anything?
No, this thing is not on mute, ma'am. So
Okay.
maybe they were talking.
Okay. How we are making the filter bed? Coarse fine media, and it is mixed with some mixed media, and fine particle where it could be, I said, fine media where could be, coarse media where could be.
Fine, ma'am. Down, and then from till up it goes till coarse, ma'am. No, sorry. From coarse to fine, ma'am. Yes, ma'am.
Okay. It's always the coarse layer supposed to be at the top.
Okay.
Then the fine layer will be at the bottom. The big particle will be filtered up at the top. The fine particle will go down. At last, anywhere it can be filtered it up and will get the pure water. If it is in reverse means at the top itself the fine pores will be blocked. No.
Yes.
You understand? So always the conceptualization of any instrument or any principle is very important. So here what the people are forced to find mixed media when they are using, they are giving the satisfactory result of 5 to 6 milligram per liter of alum, 0.5 milligram per liter of polymer they are using. Actually, when we have studied about the alum dosage in coagulation lesson, how much alum could be added, we have studied. Any one of you could remember? We have studied coagulant. Yes. How much coagulant could be added? That it's supposed to be 0.3 to 0.15 gram per liter of water alum. And if you use the other salt, it will be little less. But here what people are saying in this particular line, 5.6 milligram per liter. Which one is correct? Less. This only is correct. Less. 0.3 to 0.15 gram per liter, they said. Gram. Here they are telling 5 to 6 milligram. That means that divided by this, it is more. It is very, very less quantity. When we are using this type of filters, the usage of coagulant will be reduced. Okay. The same result if you use any sort of conventional treatment or filter unit, which requires minimum of 17 milligram per liter of alum, and also it creates a lot of sedimentation. Did you understand?
Yes,
I will tell you. Okay, fine. So, do you want me to explain again?
No, ma'am.
Okay. This direct filters process can consistently produce very high quality of water, and why it requires very less quantity of coagulant. Anyhow, that will be absorbing and aggregating the particle size will be settled down. The sludge formation is less. So the sludge formation is less means the filtration process efficiency will be going down, and that will be reflected directly on the operating cost of the unit. So the filtration rate 1.4 to 4 millimeter per second can be reduced the turbidity of 1 to 100 NTU to 0.1 to 0.3 NTU, which is really very good result when we are comparing into the conventional treatment. Conventional treatment means what here? They use a separate coagulation tank, separate flagellation tank, separate clarification tank. After that, they are sending into the filtration unit. But in this particular model, direct model, they are coagulation, flagellation, clarification, including filtration, all are operated as a unit process. So when they are doing like this, the alum dosage is reduced from, we can say around 100% almost. And also when we have reduced that alum dosage and the other coagulant dosage, obviously which reduce the sludge formation quantity. If sludge formation is less means which will not be giving much problem in filtration process. So which improves the filtration efficiency and which directly reflects on the cost of operations, which means that less cost of operation. And this will reduce the turbidity at the rate of 1 to 100 NTU to 0.1 to 0.3 NTU at the dosage level of 5 to 6 milligram per liter of alum, and the filtration rate of 1.4 to 4 millimeter per second rate.
Ma'am, we have to remember all these values, ma'am.
Few you have to remember because you are studying PG now.
Okay, ma'am. It's very difficult. Now only can't remember when you're saying.
You note it down, but try to remember few. Okay.
And all these are there in the reader, no, ma'am?
Huh?
All these are there in the reader, no, ma'am?
Yes, yes, yes.
Okay.
If you want to get the same sort of result when we are following the conventional treatment, you are supposed to use 17 milligram per liter of alum. How much it is reduced? Almost more than 3 to 3.5 times it is reduced the alum dosage. Understood?
Yes, ma'am.
Now you people only have to answer to me, what is meant by diatomeous filter? Diatomeous material means what? This geology, geography people only knows. Diatomeous material means what? That diatomeous material they are using for making the filter, which is a kind of filter media. Okay. What could be the material? What is that? From where they are getting that?
Diatoms. Ma'am, diatom is an algae, no? Is that thing? Or something else?
Actually, which is nothing but a skeleton of diatoms mined from deposit lie down in the seas. Skeleton
so diatom is an organism also.
Yeah, it could be. I am not aware of it. But
yes,
here
it is an algae that I know. But I don't think so. Algae have skeletons. Yeah,
that only it is diatoms. Here, the layer of diatoms materials are used to make the porous media, filter media, which is built up on a porous septum. by recirculating a slurry of this diatomaceous earth until the firm layer formed. That till that they are using the diatomous material. Diatomous material means what? That is the knowledge, which is nothing but a skeleton of diatoms mined from deposit which lied in the sea. That death cell which are all deposited in the sea. That only. Make use of that. The filter media is being built up on a porous septum by recirculating the slurry kind of material of this diatoms material. They are recirculating till the foam layer formed. Okay, that till where they are doing this recirculation on the septum. So their recirculation process, they are continuously doing till they get the foam layer on the septum. Then they are what they are doing, which is again it is pre-coat with this foam layer. That layer material they are using it for filtration process. Actually, this is a very good material for using this filtration process, but it cannot be considered as a rapid sun filter. But when we compare it to the slow sand filter, which is a little faster than the slow sand filter, that's what they have considered this as a rapid sand filter. According to the definition of rapid sand filter, this filter is not at all coming under the rapid sand filter, but comparative speed only which coming up into this particular model. And this which has the capability of reducing 0.5 to 2.5 kg per meter to the septum, they are using for this making this diatomous type of filter. And sometimes when the turbidity is very high, means this material is adding incoming water in the body is weak, and which gives a filtration rate of 7.2 to 18 meter cube per meter square per year area. And again, this type of filter classified into two types. One is pressure type, another one is vacuum type. You people may know what is the pressure type. Now I will explain about the vacuum type. Do you want me to explain again about the pressure type?
No, ma'am.
No. Can you tell now? You people know everybody using this cleaner. So how the vacuum cleaner is working?
It sucks in air, ma'am. Matlab, yeah, sucks in air from the surrounding or from a particular place, ma'am. It is based on suction.
Okay, the principle is only suction. How it sucks?
How it sucks mean, ma'am?
Everywhere is there now. If you provide anything, some extra thing, how it could work? Suction is correct word. Suction pressure is produced. Because of that only the sucking is taking place. How exactly what is happening? Always the things are moving from high pressure to low pressure area, isn't it?
Yes, ma'am.
It won't be vice versa anyway. If it does have vice versa, we have to give extra pressure like reverse osmosis. This is not the case. However, vacuum cleaner is working. In a vacuum cleaner, when you are switching on the motor, inside the vacuum cleaner, which creates the vacuum. Which creates the vacuum means whatever the air and air pressure inside, it is coming out. When it comes out inside the unit, which creates the vacuum. Vacuum means there is a pressure of 0 bar. So when the motor is going outside, the outside pressure is higher than the inside unit pressure. So when we are giving that, wherever you are showing your motor, you are just showing the suction pressure from the inside to the outside. The outside material which are in higher pressure than the inside pressure. So because of that, it goes inside. Clear? Not clear?
No, ma'am.
Actually, the fluids are moving from high pressure to low pressure or low pressure to high pressure.
Low pressure to high pressure, no?
High pressure to
High
low
pressure to low pressure.
The low pressure to high pressure means how it goes. Wherever the low pressure is there, if we want to move the fluids means we have to give extra pressure. That's what we want to pump the water from the high pressure to low pressure to high pressure. We are using the pump to pump the water. Then you are giving extra pressure. Yes. Understand? In a vacuum cleaner, Vacuum means what? First, you people don't know that. That's what you have this confusion. What is meant by vacuum? Vacuum means what?
Vacuum.
Zero air, ma'am.
Zero air, zero pressure. Air we should not say, sir, please. We can say when we are using in terms of air, zero air, zero pressure. That means there is no oxygen and nitrogen. That is called zero air. But you have answer is okay. Zero air we should not say, zero pressure air.
Okay, zero pressure.
Okay. That is called, actually what is the pressure of air? We are telling atmospheric pressure, atmospheric pressure. Atmospheric pressure means what?
The pressure which the blanket of air surrounding the earth is providing.
Actually, wherever the movement of fluid is there, there will be the pressure. Okay. In atmosphere, what is moving? What is moving? You people are not breathing
Air,
and
air, madam.
air is moving from one place to another place. That we are telling in terms of wind speed or wind is moving, isn't it?
Yes, ma'am.
That there is a little pressure difference because if you go to any hill station pressure is more than the normal surface pressure or less than the normal surface pressure.
There is more air, ma'am.
My God.
Less, ma'am. Less, ma'am.
Okay. Anybody cooked in hill station?
High altitude, there is less.
Okay. Anybody cooked at the hill station at any time?
Yes, ma'am.
When you are cooking, the cooking time at the hill station is more or normal surface is more? Cooking time.
More, ma'am, more. It takes more time.
In hill station, it is more.
Yes, ma'am.
Why it is taking more?
Because the pressure is low, ma'am.
Yeah, that is the point. Because according to the ideal gas law, what is the ideal gas law? PV equal to nRT. You note it down. According to the ideal gas law, the equation PV equal to nRT, where P is directly proportional to temperature. If pressure increases, temperature also increases. Understand?
Yes, ma'am.
Okay.
Okay. So wherever the pressure increases, means more pressure, the temperature will go fast. If pressure decreases, means the temperature also decreases or the rate of increasing will be slow. In hill station, for your kind information, the pressure will be less. That's what we are feeling little cold. And with the cooking time and normal breathing problem, everything will be there in hill station. So vacuum, so when the air is moving from one place to another place, because of presence of
air moves very quickly, no, in hill stations, ma'am?
No, that's what I wanted to give the explanation. You have interrupted.
Okay, sorry.
Because in hill station, many hills are there. When the air is moving from one place to another place, the hills are making the hindrance to movement. So because of that, what will happen? The mixing of air, which is nothing but Brownian motion. Brownian motion means what? Particles or molecules are moving aggressively from one place to another place. There will be interchange of particles, interchange of energy, which gives or distribute the energy in the atmosphere. Because of that only, we are moving everywhere. We can feel, we can respirate, we can all the normal attitude, behavior, everything can be possible. Otherwise, what I'm speaking, you cannot hear. What you are speaking, I cannot hear. These are all things happening is like that only. But in hill station, because of presence of hills, when the air is moving from one place to another place, the air flow is being reduced. The normal flow is being reduced. That's why in hill station, the people will flow some paper or cap means which goes very slow in the hill station. Have you seen? Have you observed? People used to throw the paper to check how it flows. They make paper cover the ship and they throw. In normal places, it falls down very fast. In hill station, it takes long time. Very slowly it will go down because the air movement is less. Even the gravity is also less. Temperature is less. Pressure is less. movement of particle like Brownian motion, everything is less. That's what in hill station the pressure is less, so the cooking time is increased. Atmospheric pressure means it is 1 bar pressure, which is equivalent to temperature you people identified according to that condition only. Everywhere, all the scientific condition people have decided to use STP condition. STP means standard temperature and pressure condition. Standard temperature is considered as 25 degrees centigrade. Standard pressure is considered as 1 atmospheric pressure, which is equal to 1 bar. This is the specific standard condition or atmospheric pressure temperature condition or standard temperature pressure condition. Now, vacuum means what? This pressure is supposed to be nil, zero. That is called vacuum. So, how you have to create? Normally, this vacuum condition will not be available. So, vacuum condition in a particular confined place or confined unit, very small area or small unit only it can be. Whatever the air molecules which distributes the pressure in atmosphere will be completely drained out, which gives the place is completely vacuum. That vacuum, when we are making the system to be even for pumping, that can be used for filtration, it can be used for cleaning, it can be used, but whatever it may be, there is a system with the vacuum systems are working on the principle of developing of suction pressure. What is meant by suction pressure? Where the difference between the pressure of atmospheric pressure or high pressure into vacuum pressure, that layer is called suction pressure. Wherever the suction is created, there the sucking will be taking place. From one layer to another layer, the things will flow easily and very fast. That is called vacuum suction. Even filtration process under vacuum will go very fast. Instead of normal pressure or pressure filtration, this vacuum pressure which goes up very fast. In the same principle only is applicable in the vacuum cleaner. When you are creating the vacuum in the unit, always if people identify that the things or fluids are always moving from the high pressure area to low pressure area. Okay, it won't go from low to high, high to low only. That's what I told you about the osmosis process. Osmosis means what? The fluid is moving from high pressure to a low pressure area through the membrane. That is called
high concentration to low, ma'am.
Yeah, high concentration, high pressure. What concentration is more means it gives the pressure, no?
Yes,
we can say high concentration, low concentration, high pressure to low pressure, whatever it may be, that is called osmosis. But in reverse osmosis means what? From low concentration or low pressure area to high concentration or high pressure area, the process is reversed by applying extra particle pressure in the low concentration or low pressure area. The particles are pushing down, pushing inside the membrane. That is called, it is called reverse osmosis. We are giving the pressure to flow the things through the membrane. Extra pressure we are giving, which is against to the normal process. So that is called a reverse osmosis. Understood?
Yes, ma'am.
The vacuum system, vacuum cleaner are also working under the same principle and same concept. When we are thinking about this vacuum filter, this diatomous materials are being used as a filter media. They are using two types of filter. One is pressure filter and vacuum filter. As of now, I have used in small scale, these vacuum filters are working wonderfully. If you are using pressure filtration, it is not, we cannot use it very simply. We have to use some specified unit or a device to control the pressure, then only we can carry out. So economically, it is not feasible. But when the fine things like this pharma industry, like that kind of industry, they wanted to do the things very hygienically inside the container, they can follow this kind of system. Otherwise, it is not required. Understood? And the third one is valveless self-washing filters and automatic siphon. Siphon, that is correct. Do you know how the siphon is working?
What is the siphon, ma'am?
Siphon, how the siphon is working?
No, ma'am.
It is an automated system. Actually, the toilet flush tank is there, no?
Yes, ma'am.
How that working based on this siphon system only. We are not doing anything now. The water will fill it up to some level. When it reaches that level, the valve will be coming down. So automatically the tap will be closed.
Yes, ma'am.
When we are taking out that water, the valve will be raised. So again the tank will be filled up. Are you operating anything for filling up and draining up? For drain up, we are using, we are taking out. But a switch on and a switch off the tap, we are not doing.
No, ma'am.
It is automatically is being done, isn't it? The same concept and principle only applied in this filter system. This name itself, valveless, self-washing, and with automatic siphon work independently and automatically without use of any electricity or mechanically working. No auxiliary fluid system to maintain the flow. And both filtration and the washing cycle, when we are wanted to do this, then economically it is feasible. And this supplied by the Degrimon for more than 50 years. One particular company, they are supplying this particular type of filtration unit more than 50 years. Now this book has been created more than 10 years over. So now 60 years it could be. Here what is happening exactly? The water in the buffer tank in the sense it is in a storage tank. After filtration, which is rises from the bottom of the filter to the filter storage tank at the top. Then the storage tank, once it is filled, the filter is supplied through the outlet. So the system is workingly vice versa continuously. When sometime the filter bed is clogged because of this turbid particle, that time water level rises in the buffer tank and also in the upstream arm of the siphon. When the maximum design head loss is reached, the siphon is primed, then the water is filtered, the filtered water storage tank closed. So this is the system. This is called a valveless self-washing system. We no need to do anything by electrical supply or manual operation. Automatically, all the system will be working systematically. Hello. Who is speaking?
Somebody is not on mute, ma'am.
Who is speaking?
Samsung SMG990E.
Who we can?
Don't know the name, ma'am.
Okay. And then the backwash takes in place automatically. We no need to provide any backwash system, especially in this particular type. And any compressed air, nothing can be used for this. And the next one is the roughing system. Roughing filter, from the name itself, we can understand that, which is used as a pre-treatment filter rather than the treatment itself. That means what? Pre-treatment means what? Anyone can say, what does it mean by pre-treatment?
Before the actual treatment starts, so that it does not provide any hindrance in the upcoming treatment plans.
Okay, fine. Exact treatment, that is correct only, but scientifically I will give you. Pre-treatment the sense, if any material you are going to use for some process, that process, if you decide, for example, you want to make what cooking you want, everybody knows about cooking, so I can talk about that. You wanted to make rice. What are the things you want? You have to get ready of cooker or whatever the vessel you want to cook, and rice, salt, water, and whatever the power,
Yes.
Gas or electricity, whatever it may be. So now you wanted to cook the rice, immediately you take it and put it, means it takes little longer time. Okay, if you do some sort of pre-treatment, like you soak it for some time, that makes the process easier in the further step or in the cooking. If you soak the rice for half an hour, then you cook. Instead of cooking 15-20 minutes, you can cook it within 10 to 12 minutes. That rice also will be good. So you are doing some sort of pre-process, which makes the main process to be easy. And what are the factors will be hindering in the main process will be reduced. Second point. Third point is, please mute somebody other. If I mute means it won't look good. Who is Samsung SMG990E? Shall I move? Yes. Yes, yes.
Yes, ma'am. I can't hear you, I guess.
Harshita is not there in the class?
No, ma'am.
Okay.
Only Bhargav is also there, yes. Asha is also not there.
Okay, Asha also not there. Okay. Pre-treatment in the sense, what does it mean by pre-treatment? You understood that for the rice making, what did you understand? This
Yes,
rice making, if you soak the rice, which reduce the gas, which makes the process easier in terms of energy and also less time, and also quality of cooking is easy, which makes the entire process is very simpler and increase the efficiency of the process. Similarly, any pre-treatment if you are doing in any process, which makes the process be very easy and unwanted things can be eliminated, wanted things can be added, and makes the things very simple in terms of economic, in terms of process, that is called pre-treatment. So this rough filter can be used to remove the high turbidity is there in the water, especially in a slow sand filter in general. This roughing filter will be helpful to remove lot of turbidity and also which reduce the load of turbid material in the forthcoming process. That kind of filters are called roughing filter. Especially in upflow filters, we know that there are three types of layers they are using with a different thickness from bottom to top. With a simple under drain system, they are using which is serves like a roughing filter. This roughing filter, when they are using continuously, which makes the process very faster up to 20 meter per hour, 20 then the overall efficiency is improving, and also the time spending for backwash will be reduced, and which is about 20 to 30 minutes. So this is the concept of roughing filter. Clear? So they have given some example for that. You people will go through it. But that is not much technique. If you use this coconut shell, how it could be the thing. If you use graded coarse material, how it could be said, like that they have given. The next important part of filtration I'm going to talk about is theory of filtration. This theory of filtration is little difficult to understand only, but I try my level to make you people to understand. If you cannot understand, you ask me again, okay? Actually, the process of we are thinking that the filtration is very important, very simple. We are pouring the tea, it is easily filter it. We are getting the clear tea. We are using the coffee filter with mixer. We are getting the clear coffee with a good aroma. Why are you explain this much about the filtration? And you are an idiot or not? You can think it. When you people are using only the porous metals, it is easy. When you are using the porous media, the mixed material for performing the industrial process, it is quite difficult. There are n number of concepts and mechanisms are involved, but I am going to talk about only 5 different mechanisms, how it is involved in the filtration process. That 5 mechanisms are together, which is called theory of filtration. Understand? One is, no one is responding.
Yes, ma'am. Yes, ma'am.
And the first one is transportation of particle from the body of water to the sand surface. How we are passing, when we are passing the water into the filter surface, how the particles are transported from the water to the sand surface. How it is. That is very important. And the second one is how these particles are attached to the sand surface. And the third one is how it is flagellate with the sand particle. Fourth one is sometimes which gives the biological growth. That means contamination also. And a detachment. Detachment means how these turbid particles will be coming out of the sand media. These 5 are very important factors of this filtration process. First one is factors responsible for transport of particles. And this is involved in 6 different concepts. One is training. Second one is inertia. You can open your slides now about the filtration. What we have sent in the last class, still it is there.
Okay.
Filtration. You can open it up because otherwise you may not know the spelling of term which I have mentioned.
Okay.
Open it. Open it.
Open, ma'am.
Okay, fine. In that theory of filtration, please open. Everyone, please open.
Yes, ma'am. Slide 5.
Okay. In that first one is transportation of particle. With what I have said, people have understood.
Yes, ma'am.
You understood? Okay. So the factors responsible transport of particles are 6 important factors are responsible. That is, one is straining, second one is inertia, and the third one is interception, and the fourth one is called sedimentation, fifth one is hydrodynamics, not hydrodynamics, and the sixth one is diffusion. If you people are well aware about all this term, we can go fast. Otherwise, I will explain one by one. First one is how this straining is responsible for the transportation of particles. Actually, which again it is involved with two important concepts. One is mechanical, another one is chance contact. In a mechanical straining, here in the particles are larger than the pore size are strained out. Understand? The
Yes, ma'am.
turbid particles are bigger than the pore size of the media will be strained out, which will keep flowing through the thing. And the second one is the chance contact. Particles are smaller than the pore size are trapped by the surface contact or by the porous media. The particles which are smaller than the pore size of the media or sand media will be trapped by them. And the second one is inertia. What is meant by inertia? In this particular concept, whenever the upflow filters are there, the particles, because upflow means water is coming from the bottom to top. In that particular case, particles do not attach to the upstream faces of the grains, but deposit on the top of the grains, which indicating the inertia not an important for the parameter for trapping the material. Because when the flow is from the bottom to top, it is quite difficult to adhere the particle on the media. Because when the top surface is coming in the water where once it will reach us, it will be drained out. So this concept is not much important involved in the particle transportation from the water to the sand media. And the next one is interception. In this particular case, the particle which move along the stream, that means along the streams, along the water, along with the water, and or removed when they come in contact with the surface of the sand. That is a normal process. In this particular case, this water and tragedy particles are coincident. Water and the particle both are coming with the same direction, isn't it? That means that mixture only we are passing through the bed. When it is coming like this, whenever the particles are coincide with the water stream, that time which gives some sort of importance to the particle to adhere into the sand surface. This is an important factor to be considered, how the particles could be transported from the water into the sand surface. Because here coincide means what? Each molecule of water and the molecule of that heat particle, when it coincides, that we cannot see with our naked eyes. But if it's physically, when it happens, that particle can be easily transported into the porous media. And then sedimentation. This is one of the major parameter response for the removal of particle. We also know that, but here only one condition is there, that water and the particle trajectory do not coincide. In the last case, we said both are supposed to be coincide, then only that interception will happen. But here, the stream particles and water should not coincide. When it is not coincide, then the particle will be settled down in the filter media. Could you understand? During the flow, the particles will be absorbed in the filter media where the water and the particles are coincided. That is called interception. In sedimentation process, the particles and the water will be flowing where the coincide should not be occurred. That means there should not be any flow of water. The water is supposed to be stagnant. There the particle settling is taking place on the filter media. Did you understand between sedimentation and the interception?
Yes, ma'am.
Okay, good. The next one is hydrodynamics, which is nothing but the particles are moving from high velocity region to the low velocity region. So where due to the pressure difference, sometimes the particles will be drained out. This is normal process. When the flow is occurring, the large surface area where the velocity of the flow stream will be reduced, their normal settlement of particles are taking place. That is hydrodynamics. And the diffusion. Diffusion means anyone can explain what is meant by diffusion. I have spoken many times about the diffusion, which is nothing but the particles are less than 1 micron are removed by the diffusion process. That is, Brownian motion is wherever it is significant, there the particles are removed up to the size of 1 micron. And factors response for attachment of particle with the sand grains. Now, how it is transported to the particle we have seen till now. Now we are going to the how the particles attached to the sand material. There are 4 different forces are involved in. 5, but 2 different processes are involved in. One is physical absorption and another one is chemical absorption. Not absorption. This up to 4 level which will be happening. The physical process or absorption is taking place in the form of electrostatic forces, electrokinetic forces and van der Waals forces. Chemical absorption taking place in the form of bonding and chemical interception. Then the flagellation, how the flagellation is happening. When the large particles overtake or aggregate from the smaller particles, they join them and form still larger particles and are removed by any above mechanism of the transport of the particle from water to the filter surface. So that is called flagellation. Biological growth means that it is very, very important problem which are associated with this, especially sand type filters. Because sand type filter, it is not that much easy to just to take it out, you wash it and put. For example, you can take out your tea strainer. After tea making, you can remove that tea dust and you can wash it easily. But this cannot be done like that. How? Why? This is a dominant in slow sand filter because of the pore volume reduces and where the growth of microorganism will be there. When it is continuously growing, which completely block the pore size or pore volume of the filter media. And then how we have to detach the particles from the filter media. This is regeneration of filter media, how it could be done, which is very, very important while operating this sand filters. The deposition of particle on the sand surface takes place as long as the sand grains sustain it. If it is not sustained, it is later. Later on, detachment of blocks takes place. So, how we can be done? It can be done by the process of backwash. Then next, this is about the theory of filtration. Theory of filtration means it is not associated with any sort of equation or something like this. Here, what are the mechanism are associated with the filtration process have been explained. What are the process? How the particle could be transported to the filter media? How the particle could be attached to the filter media? Then how the flagellation is taking place? Then how the filter bed is affected by the biological growth and how we can be detached the particles, turbid particles from the filter media. So these are all the factors associated with the filtration process is called the theory of filtration. And the transporting a particle which involved with the different mechanism and factors is a response for the attachment of particles which involved with the forces and the rest of the process automatically is happening which is based on the condition what we have provided to the process. This is about the theory of filtration. Is it clear?
Yes, ma'am.
Do you have any doubt till now?
No, ma'am. This was a little better, easy to understand.
Really? Because I'm from right from
better
first.
than others, ma'am. Better than filters.
Okay. This is also filtration concept only, na?
Yes, ma'am. But maybe because you are repeating everything so many times, now it's getting into the head.
That is the reason. You people are doing PG, master degree. Actually, I will tell you one small example.
But then we did not do all these topics, no? in
That
between
is
in
the,
graduation.
that is the point. This PG doctors are doing master of this, master of that,
Yes,
medical
ma'am.
people. For
Yes.
them, no one is teaching, you know that.
Huh.
In most of the college,
Yes.
students, they are taking seminars, that only classes. But the seminar in the sense, they will go into the depth of knowledge. They have to take the seminar. That is the marks for them.
Okay.
Okay. They will not do simply, they will not take simply seminar. Casually, they won't take. They study well. They will report the knowledge like anything. And they have to satisfy everyone. Like that, they have to give the seminar. One by one will take the seminar. They cover the syllabus. Then they have tried the exam. You understand? I made a mistake. I would have done like that, you know. I would have asked you people to take the class. You people would have prepared very nicely. That's the mistake I have done. Okay. Can I give one more chance? Next class, anyone is ready to take this, please tell me.
Not in this chapter, ma'am. Please. Chapter.
I made a mistake. Now only I realize. Okay. Shall we go to the design?
Yes, ma'am.
Okay. Only we three are there. You and me and Dalia, madam.
No, ma'am. 5 people are there.
One by one left.
There were only 6 or 7. 2 people left, I guess. And we 5 are there. Bhargavi, Dalia, Jafar Baba, M. Krishnamurthy, and Puri Venkat.
Okay. Bhargavi joined and left.
No, Bhargavi is there, ma'am.
No voice.
Maybe she's not talking.
Okay. So next one is design. How we have to design? The design of rapids and filter is governed by many factors. This is really little vast only. Many are there. I am going to talk about only few. One is what quality of water we are going to use for filtration. That is raw water quality. Second one is the nature and the efficiency of pre-treatment process. And I told you, this roughing filter, which is nothing but the pre-treatment process. Based on this, the entire process will be taking place. For that only, I have given the rice cooking. If you wash and soak the rice for some time, which will give the better rice, and also it will take very less time. Many things I said like that. The nature and the efficiency of the pre-treatment process is an important factor for designing the unit also. And the characteristics of filter media, whatever the material you are chosen for the filters media, that is also depends. The hydraulic loading of filter, how much water you are going to filter it off. Next one is the method and the interval of cleaning, how frequently you are going to wash the filter bed or filter media. The method of disinfection. Now we have talked about the biological growth. Then if once the biological growth is there, means how we can do the disinfection. That is also important parameter to be considered for design. And the required quality of filter effect, because for all the process it need microfilter, many ultra filter, many filters are there. Have you seen anywhere ultra filters?
Ultra filters, no, ma'am.
All the water filters nowadays people have introduced that contains UF. UF they will say. UF means ultra filters.
Oh, okay.
Okay. So based on the ultra filter means which are doing pakka filtration. Very good filtration or fine filtration. So the degree of what kind of or degree of filtration we want, based on that also we have to choose the material. And the next one is the design of rapids and filter unit includes the design of the following. Simply we have considered few parameters for design. Now what are the other things to be considered for design? Other unit, many units are involved with the filter. Water inlet, water outlet, and the depth of the sand bed. What are the filter media material we can use? Whether all the material is available or not, and overhead tank. Many things are there. How the pipes and wash water, where we can under drain system, how to use, how much depth it could be. Everything is a matter. So other unit to be considered for design of rapids and filters are size of filter unit. how much big it is. It is being decided based on the how many liters per hour or how many liters per day, like that. When you are buying the water filter, they will give 10 liters capacity, 15 liters capacity,
Yes,
7
ma'am.
liters whatever. That how long it takes it. If you ask the question, the tank is 10 liters, mean the 10 liters how long it takes to fill up. That is called capacity or size. Did you get my point?
Yes, ma'am.
Okay. And the selection of filter media from available sand. I have told you about the filter media many. So how much it is available based on that, because now you have chosen one particular sand material that is not available in India, that you have to bring it from Australia. Will you go and get it? No. Whatever locally available, from that the best material you have to choose. And the depth, how much depth you have to use that sand bed. Under drain system, what kind of system you are going to be adapt for under drain. And wash water, how you are going to wash it, and wash water system, how you will provide. That is called wash water gutter. Air piping for air scope. Sometimes I told a pitting will come that makes us void, that has to be avoided. For that air piping, how to provide that. Overhead tank for backwash. Many times we have spoken about it. And pipe conduits and operations. Pipe conduits means what? The system is being used to transport the water is called pipe conduits. Could you remember? When we are studying about the water distribution, how we will do the water distribution? Once we take the water from the river through the intake, then it has to be transported from the intake to the treatment point. For that, there are two types of conduits can be used. One
Yes,
is
ma'am.
after a long time, pressure conduits and gravity conduits.
Yes,
Conduit means is a kind of pipe used for transport the water or sending the water is called pipe conduits. Clear? Then a number and a size of filter units. This and all you want me to explain, you people can go through it.
Yes, ma'am. We go through it.
That and all not much technique, you can easily. Okay, otherwise I will tell you. Actually, the capacity of the rapid sand filter should be number of units can take care of the total quantity of water to be filtered. For example, if you are taking the water, the smaller the number of units, the fewer the appliances, but larger the wash water equipment that will be required. There is some concept. For example, a single unit could be 100 square meter means, which can be consist of two halves of 50 square meter and 50 square meters. But it should not be more than 100 milliliters or million liter per capacity. Like that, they split up means if one is working, one is not working means they can do the service easily, because it is a filtration system. At any time it can be clogged. At any time that contamination will take place. If it is more means, then we have to do the backwash often. Once you do the backwash means you have to dry the bed and we have to regenerate the bed. Otherwise the efficiency, filtration efficiency will not be good. So once the people, for example, in Hyderabad, how many million liters of water per day they are filtering, we do not know. Because which depends upon the population demand, based on that the designing is followed up. For that only, they have given some example. In case if you want to have 100 million liters per day unit means, you should not make the unit with a single unit of 100 million liters. You are supposed to make the unit of 50 million liters and 50 million liters to capacity. Why do we have to make it at any time? Anything will be happening means at least another one can be used. Another one can be under operation. That is the reason, which is something like a standby system. Like that, always this filtration system supposed to be adapted. It does not mean that one only supposed to be run, another one is to stop. Both can be run, but the thing is, you should make it as a two system. Clear? Oh, everybody slept.
No, ma'am. Yes, ma'am.
Okay, next one is depth of the filter bed. The structure should be whatever we are making, that supposed to be which is adequate for given volume or required or demand of water. At least 1.2 meter of water over the sand so as to discourage air holding. Air binding means what, you know that? And to enter the reasonable length of the filter runs. Anyone can see what is meant by air binding?
Air binding.
No,
No,
I told you in the class.
air binding.
Some other term I would have used, but the meaning is the same meaning I have. First, when you are using that sand bed, here and there some gap will be there. In that gap, air will be occupied. Understood now? Did I tell you? When you are passing out this water, wherever the air binding is happening, there it started escaping. So small air bubbles will come. So sometimes people will say this kind of packing media, that air gap or that air binding places are called void.
Yes, ma'am.
Okay, yes, now you understood. The minimum total depth of filter is supposed to be 2.5 to 2.5 meter, but preferably when we are using a little more coarse material means 3 meter is preferable. More than that, it is very difficult to handle. 2.5 to 3 meter itself, it is not small, it is very, very big. Imagine it. 2.5 meter to 3 meter thickness sand, but if you are making for water filtration, if anything happen in the middle means how you will rectify?
Yes.
Understood? So
Yes.
that itself, it is very big. Then another one important thing is filter sand. Filter sand is, you people just have the knowledge of it. Few values you just remember. No one can remember all the values. Okay. I myself will advise like this. Whether it is good or not, I don't know. Okay. What are the design criteria for selection of sand? These are all physical characters only. The filter sand should be selected with care. Many parameters supposed to be considered before we are selecting the sand. The factors like effectiveness of pre-treatment, the rate of filtration, and the depth of sand affect the size of the filter. So the filter again, it is being whatever the filter sand you are selecting, that filter sand is supposed to satisfy many criteria. What are the criteria? We'll see. Sand shall be the hard and resistant quartz, because the sand material is supposed to be very hard, like quartz material. If it is very soft sand means when you are handling it, it will be crushed. If it is crushed means you cannot maintain the uniformity. The uniformity coefficient is very, very important when we are choosing the material, coarse material for filter media. So it is supposed to be very hard when we are handling, that should not be crushed up. And it is supposed to be free from the clay, fine particles, soft grains, organic matter, and dirt of every descriptions. Why it should not be contain any clay and sand particles? Fine particles or soft grains. If you are there, what will happen? It will be going away when the water flows continuously, isn't it?
Yes, ma'am.
If organic matter is there, what will happen? If organic matter will be there, it will be continuously decomposed. When it decomposes, that the place will be deteriorated.
Yes, ma'am.
So, and also it's supposed to be free from the dust. These are all things look like very simple, but if all these dirt materials there in the graded sand means it is not good to operate the unit continuously. And the specific gravity of the sandbars should not be less than 2.5. It is very, very important. And the silica content should not be less than 99.8%. Silica means what? Silicon means what? I would have told you. Silica means silicon dioxide, SiO2. Silica is not available naturally. You have to reduce the process. That is very difficult to process, I told you. Okay. And hardness of ore stand shall be between, hardness you can say. They have some scale, the name of the scale called Mohs scale. That should be in the range of 7 and 8. These are all the standard values, okay? When soaked in 10% hydrochloric acid for 24 hours, the loss of weight shall not be preferably exceeded 5%. This is something like if any industry are making something or manufacturing something, they will say that out of 100, more than 3 pieces should not be damaged. You know that concept?
No, ma'am.
Any industry they are making means either food industry or cloth making industry, anything, there is a logic million three concept there. The three, more than 3 units should not be damaged during the process out of 1 million or 1,000 like that. So here also when we are choosing this sand material, if you are soaking with the sulfuric acid, if it is stabilized for 100% or 95%, then that sand can be easily selected for making a filter. That means if it is more than that, means if it is reduced, means which can be indicated or which can be from that we can confirm that the sand contains some sort of fine particles or soft grains or organic matter or some other that material, dirt material. Because of that only when we are doing this sulfuric acid treatment, it is being degraded. So the volume is reduced from 95 to more than. If it is reduced more than 5%, then the sand cannot be used for making the filter media. It will be rejected. Clear, Rita?
Yes, ma'am.
When we subject to 40 to 50% expansion of this medium material, original depth of sand for a period of 100 hours, the percentage loss shall not be or should not be exceeded 5%. How we do the expansion? We have to heat the sand material at a constant temperature. When we do it that for 40 to 50% expansion, when we are heating means any substance will expand it. If you are doing that, the expansion should not be exceeded 5% like what we have seen in the previous point. This test people are doing for continuously 100 hours. If the expansion is not more than 5% means it will be accepted. If it is more than 5%, then the sand will be rejected. The loss on ignition. Loss on ignition means it is any, why we have to find with this test, if any organic substance is there in the sand, it will be burnt off if you do the burning or ignition. Ignition means burning, you know that?
Yes, ma'am.
Okay. When we are doing this ignition test, we are igniting the sand. If the percentage of the sand which will not be less than 0.7, the sand will be agreed. If it is more than 0.7% loss, it will not be agreed, which means that the sand contains a lot of organic matter. So if it is there means continuously it will be degraded. So easy pitting or loss of sand material is happening. So this test is very, very important to find the quality of matter without any organic substances. Then another important substance, and you may not be know that the average sphericity of sand grain means the size of the particle. Okay, DH by DS. DH means hydrochloric diameter of grain, and DS means diameter of actual grain. That means after giving the treatment of hydrochloric acid, before treatment of giving the hydrochloric acid, the ratio between these two should not be less than 0.7. It should not be exceeded less than, then if it is more than that, it will be rejected. Okay. Then rounder sand grains are preferable to angular ones. Because the sand, we cannot say everything is in a round shape. There are different shapes. Something will be multi-phase shape. It may be diagonal. It may be hexagon, pentagon, triangle, rectangular, square, round, any type. Many types are there. If you say, take the sand particle, you look at that, you cannot find out what is the shape of it. But the preference is round side only. And the effective size D10 of sand is in the range of 0.45 to 0.7. That means diameter one will be graded D1, D2, D3, D4 like that. D10 is preferable than the smaller size. If it is in the range of if you are taking 1 kg of sand, in that the D10 range is approximately 0.45 to 0.7 mm, means it will be selected. If it is less than that or more than that, means it will be rejected. Then the uniformity coefficient, which is at diameter 60 divided by diameter 10, they will do. For rapid standard, the ratio is supposed to be 1.5 or less. These are all the sand filter media, rapid sand filter media selection concepts. Now, once you select all the material with that mentioned criteria, then you have to think how to prepare the filter sand. You understand?
Yes, ma'am.
So what is the time now? I became tired. Time has gone up.
3:45, ma'am.
When we have started?
We started at 2:30.
Okay, 15 more minutes. I'm unable to speak. Sound is coming.
Yes, ma'am.
Yes, okay. Now we have chosen the material with the standard specification. After selecting the material, now how we have to prepare the sand filter, that is very important. So there are some criteria to prepare it also. Now, you suppose your natural river bank, and you take the natural river bank sand, which may be too coarse, sometimes too fine, or too non-uniform for a filter to be constructed. Because we cannot say the sand when we are collecting from the seabed or sea bank or riverbed or riverbank, it may not be having the uniformity size. It may be very too coarse. Sometimes it will, some area it will too fine, or it is mixture of both. Anything would could be. So those material we cannot directly use for constructing this filters. If the filter sand is specified in terms of effective size, whatever the size I said, D10, that should be in the range of 0.45 to 0.7 millimeter. That's right. And the uniformity coefficient and the sieve analysis. I told you that this kind of effective size, uniformity size of sand particle, how you would do that effective size testing? I told you diameter 10 means between the range 0.45 to 0.7 millimeter would be good. And the uniformity coefficient is supposed to be D60 divided by D10 supposed to be good for the ratio between these rules should be 1.5 or less should be good for rapid sand filter. I said, how you will grade all those things? Can you take the sand?
Bigger size to small size, madam.
How you will grade it? Smaller size, bigger size. You are taking the sand from. Okay, ma'am.
Choose to mm.
Okay, how you will use a screw gauge to find out the middle diameter of the particle? You got my point.
4 mm to 6 mm.
How you will decide? This is 4 mm to 6 mm. Will you make use of some instrument?
Diameter of sand filter, madam.
Ma'am, those many in the filter there will be layers.
The volume,
it
sand
will
filter
be
volume.
Good, ma'am. So we will know.
Calculated to sand filter volume.
Yeah, I think I am not asking the question in a right manner. Now I have told you that different diameter particle we have to choose. This particular diameter particles are good, and the range of diameter particles also I said. Yes. Now you are taking the sand from the riverbed. Okay. Now you have to get the sand according to your requirement. And you are doing this hydrochloric acid test and ignition test and expansion test, all the tests you are carrying out. At last you got the good quality. Then you have to grade it according to the diameter of the particle. How will you know that the diameter, how will you come to know the diameter of particle? How will you measure it? One particle with a screw gauge or screw gauge or vernier caliper, will you check it?
No, madam. It is called pebbles, madam. That's mean pebbles.
Huh? What pebbles?
It's called pebbles, madam.
Pebbles, okay. Pebbles are there, that is okay. How will measure the diameter of the particle? I told you D10, D60, D7, many things I told. How will you come to know? How will you measure the diameter?
Okay.
Understand my question?
Okay, madam. Yes, madam.
How will?
Don't know, ma'am.
Okay. Actually, there are standard sieves. Sieves of different diameter 4.
I told you this, no, ma'am. You didn't say anything.
I didn't hear your voice. Otherwise, I would have appreciated definitely.
I told different layers of these many. This thing is there, ma'am. The pores.
Yes. I think you would have told me sieves means I could have got it. Okay, correct with them. Actually, I will explain to you others. Actually, there are different types and a different shape or size of sieves are available. That is 2 mm, 4 mm, and 2 mm to 4 mm, 4 mm to 6 mm. Like that, different sieves are available. When you are doing the sieves, that particular size of particles will be retained. From that, you have to take out and do the average test. Understand? This is the only way we can grade this kind of coarse material. Because we are studying about all coarse material grading and the mixing of all this material, and we are making the compaction of all this material to make filter. And so fine coarse materials are there. Then we have to do this sleeve test and find out the different size of the particles. Then and unwanted things are being removed. Then the function of P10 and P6, namely percentage of stock and percentage of stock sand smaller than the described effective size and the 60% size respectively. What they are doing, that effective size I told you, and also uniformity coefficient I said. That uniformity coefficient, which is nothing but diameter 60 divided by diameter 10 particle ratio, that means uniformity is supposed to be there in the selected sand after sieving. That they have technically categorized P10 and P60. P10 and P60, which is nothing but percentage of 10 and percentile of 60. Percentage, no, percentile. Percentile means overall aggregate size of the particle in that particular range, it is called. Then they have categorized, if it is in that range, then it will be chosen. If it is not in the range of 1.5 ratio of D60 by D10, then the sand will be rejected. Clear?
Okay.
Next one is depth of sand bed. Now we have chosen everything. Then how much depth you have to make the sand bed, we'll see. The minimum depth of sand bed should not be less than the 60 centimeter, while maximum depth it also should not be more than the 90 centimeter. It is in between 60 to 90 centimeter. So the sand depth is normally between, generally or conventionally, people are following between 60 to 75 centimeter. Clear? And next one is they have explained very clearly about how the sand bed is responsible towards the pre-treatment process. That is variation of breakthrough index with the treatment. Response to coagulation, how much? Degree of pre-treatment, how much? And the values of B in the sense the responsible test from the breakthrough. That is called B. They have given the value of B. The value of B breakthrough value is less means the response to coagulation is better. And the pre-treatment, degree of pre-treatment means from B value more to less, which gives better result. Always the response to coagulation and the degree of pre-treatment are in an inverse manner, not in a direct manner. Because degree of pre-treatment we are giving for the process, which is a process of reducing the load or effectiveness of the turbidity in the forthcoming process. It is something like pre-treatment. The pre-treatment will be effective means then the response to the coagulation is okay, good. If it is average means which is giving very poor response to the coagulation process. That is the meaning of it. The filter gravel shell consists of hard, preferably round stones and not crushed stones. Hello?
Yes, ma'am.
Yes, anybody is telling anything?
No, ma'am.
Somebody said something. Okay, leave it. Always when we are using this gravel sand bed material, which is choose are preferable the round shaped material than the coarse shaped material. And also that specific gravity should not be less than 2.5 to 3. Already we have seen. And it must be free from the clay, sand, loam, and the other organic impurities of any kind. If it is clay is there, it will make that the kind of what we can say wax kind of thing. Sand is there, it will come out. If loam is there, which easily percolate. If organic,
ma'am, gravel is also a kind of sand, ma'am. Gravel is also a kind of sand.
Madam, your voice is not audible to me.
She's asking gravel is also a kind of sand. Yeah.
Yes. It is looking like some black color kind of thing. Have you seen? The people are constructing the house earlier days. They make the base with a small, big stone. Did you know, ma'am? Hello?
No, ma'am.
Okay, people are making road with some stones. Have you seen that stone?
Yes, ma'am. Yes, ma'am.
Those type of. Understand?
Yes, yes.
Okay, the gravel should contain not more than 2% of mass of any thin, flat, and illuminated pieces. Always the preferable, they are saying that round shape. Other shape not preferable. If you choose that shape also, you should not be contain any clay, sand, loam, and organic impurities, or any kind of that also. And the gravel should be excessive amount of limestone or shells and acid solubility, because this test also supposed to be done. For the gravel size of 10 millimeter or larger size, 10% solubility it should have with acid, with hydrochloric acid solubility. If the size is smaller than 10 millimeter, you should have 5% minimum solubility. If it is many more than that, then when we are passing the water continuously, it is making the pit. So to avoid that, the solubility test people are carrying out. Because in water, when we are doing many treatment, without treatment, what else will come with the water, we do not know. I told you already, sometimes human body also will be there, animal body also will be there, plant body also will be there. What kind of chemical will release and what chemical will be mixed with that, we do not know. So anyhow, all the things will be affected where the water is staying for quite a long time. If we take a continuous process of water treatment in each and every stage, this is only the process of staying in the same stage of process for quite a long time. If contains some sort of chemical which may affect the process instrument and process devices. So if it contains any other unwanted substances in the soluble form in water, that will affect the filter media too much. To avoid that only, people are doing all this solubility test, ignition test, and the soaking test. So gravel, when they are taking the material, they are doing 10% and 5% solubility test based on the size of the particle. For 10 mm and more size, 10% solubility. 10 mm and less than that, that is 5% solubility test they are doing with the hydrochloric acid. The next one is gravel bed. Gravel bed means what? Which is surround an under drain system and support. In sand bed above, just above it, they are providing. The depth of this gravel should be selected accordance with the pipe of filter bottom and the strainer system used. Because somewhere I told you in some of the cross flow filter system, when the water is flowing across the bed, then there is a problem of fluidization. So to avoid the effect of this fluidization on the entire bed filtration process, we have to provide some strainer pipe in the middle or at the cross side. If we want to provide that system, then we have to provide some sort of gravel bed over there, because we are providing the pipe also which makes which deteriorate the sand bed. To avoid that in that particular cross section area, and wherever we are providing the drainage system, there we have to provide this gravel system to avoid the deterioration of sand bed. Understand? Hello?
Yes, ma'am.
Everybody went on mute. Do you want me to explain again?
No, ma'am.
Okay, fine. And usually the depth of gravel bed is between 40 centimeter to 60 centimeter depth they are giving. And the depth can be reduced when the filter bottom or special drainer serves as a function of lowest area of coastal gravel. This depends. And they have given particular size of the depth of gravel layers, range in size, range in depth. They have given, we can just go through. Again, I'm saying if the depth is going down, the range of particle size will also be going down. And some scientists, they have given some prediction. They are also telling that range in sizes are corresponding that the gravel layers are wrapped for, especially sand, that rapid sand filters. And this gravel is not needed with the filter equipped with a porous filter plate that directly support the sand. Because somewhere we have read that people are providing some sort of porous plate to support this filter media. So that plate itself which has the porosity, so flow will be occurring easily. If any fluidization or pitting is forming, those particles will not be drained out from the filter media, by providing the porous plate at the bottom and top. If that is the case, there no need of providing this gravel material for supporting the porous media or sand media. Is it clear?
Yes, ma'am.
Okay, madam.
Okay. Now it is 4 o'clock. We'll start at 4:30.
One more
Okay,
class.
madam.
Yeah, you don't want? Don't want to tell me.
I can't attend, ma'am. I don't know about others.
You people please tell me. VS means we'll have, otherwise tomorrow or day after tomorrow onwards we have regular class in the evening.
Yes, ma'am. I can't attend today's, ma'am. You can ask others.
You others please answer to me. We'll have another class today or we'll not have tomorrow. We'll have a day after tomorrow.
Okay, ma'am.
Only 4 people are here, ma'am.
Only 4 people only are here always.
No, ma'am. In the morning class, many people will be there. Afternoon class, very less people will be there.
They ate and slept. Sir, what do you people say? We don't want me, so I have to communicate.
Ma'am,
If that is
today,
the case, 4:30 to 6 we'll have.
ma'am, today it's 10 now.
Today, no, wa?
Yes, ma'am. It's better, ma'am. Today is Sunday, na? That's
Sir,
why.
okay. Sir, okay, go and take rest. Bye.
Okay, bye, madam.
Thank you, ma'am.
Thank you, ma'am.
Thank you, thank you. Thank you. Any doubt? Any one of you want to clarify anything? Mean ask me right now itself.
No, ma'am.
No.
About the homework, we'll talk in the next class, ma'am.
Okay, many people
will
are
be there.
not there, na? Yes,
Yes, ma'am.
Okay, those who have not done homework, for them there are 2 minus on assignment.
Ma'am, homework is your subject, na, ma'am. It's on physics, na, ma'am. It's multi.
You have to try, no? You are doing multidisciplinary course, na?
Should I tell you, ma'am? No, we'll discuss in the next class only, ma'am.
Next class, yeah, everyone will be there in the next class. Means then next class I may take in the first half. So we will discuss.
Yes, ma'am. Because
Okay,
the subject
madam.
is very straining, ma'am. So we have
Okay.
to put a lot of concentration to understand it.
Actually, what is the question? I forgot.
Ma'am, why is diamond white or transparent in color and coal black in color?
Yes. What a wonderful question, you know.
Yes, ma'am.
Okay. Then we'll discuss. Definitely we'll discuss.
Okay, ma'am.
Thanks to every one of you. Any clarification you want me, you can ask me right now on what I said.
No, ma'am.
No
Okay,
question.
ma'am. Okay, thank you.
Okay. Thank you. Thank you.
Thank you, ma'am.
Thank you, ma'am. Thank you, ma'am.
Thank you.